everybody. Today I'm going to try to explain the example 5.8, weighing fish in an elevator. So a person weighed a fish of a mass m on a spring scale attached to the ceiling of an elevator as illustrated in the figure. So we can see here two different figures. What that means, when the acceleration is in positive direction, or when we go upwards, we feel a little bit heavier. If you ever imagine that in the elevator, like when you're in an elevator, when you go to the upper floors, when you go up, you feel a little bit heavier. And I'm gonna explain you why is that happening. And also we have when we are going down, we kind of feel lighter because the acceleration is in the same direction as the gravitational force. So let's see what is happening here. Show that if the elevator accelerates either upward or downward, the spring scale gives a reading that is different. So when we know that when we pull the spring scale more down, that means the tension. So when we pull this spring scale down, if it extends, then that means that there is more weight on the scale, it's showing more. But if it's, like, let's say the length is smaller, so bigger length and smaller length, then the scale is showing less weight. So if the tension is higher, the weight is gonna be higher, So, and if the tension is smaller, the weight is going to be smaller. But that's not the whole point of this. This is just picturing how those things are functioning. So let's go to the example. Okay, so we can go with the summation of the forces, where we know that T minus Fg equals to MAY. Okay, and what is Fg? Fg equals to mg. Mass times gravitational force, which equals to MAY. MAY. So this is mass. Okay, let's go through the components. So Fy is all the forces on the y-axis that are present, and then we have tension. Then we have gravitational force that is differently written as the mass times gravitational constant, and then we have mass times Ay, which is Ay is the acceleration that is present on the y-axis. So from here we can see that tension equals to what? We are just going to leave the MAY, and then here we are going to put this here, and it's going to be plus. So it's going to be plus mg, and then we see the tension now. So tension equals mg outside, Ay over g plus 1. How we get to this step? We're going to just take mg outside. Since the MAY did not have any type of g, we're going to divide it by g, and then plus 1, because that's the same thing. That's just the calculation and the procedure of calculation. Anyways, let's go to the another page. That's where we understood actually that if the acceleration is positive, or if it's a bigger acceleration, then the tension is going to be bigger. And we said if the tension is bigger, the weight showing over here is going to be also bigger. So let's go to the next page. Let's go to the part B, since we explained and finished with part A. So for part B, here we go. So I don't want you to see the whole answer. Here is the part B. Evaluate the scale reading for a 40 Newton fish in the elevator moves with an acceleration AY plus minus 2 meters per second. So, we're going to do that, shown there, T equals FG, we are going to use this formula, AY over G plus 1. So, T equals to, we know that FG from the formulas, from the information that we get is 40 newtons. And then the moves with an acceleration AY, which is minus or plus 2 meters per second squared. Okay, so let's do it. We are just going to plug in the numbers. Here we can see that everything is crossing out, plus 1. And the solution for that, we can use your calculator, but I have already that calculated. It's 48.2 newtons. And that's when the acceleration is in positive direction. So that would be the case when that would be this case. Because we are looking at the y-axis. So that would be that case. And when in the case when the acceleration is in negative direction, the tension is going to be this. It's the same procedure. We are using the same formula. It's going to be just minus 2 meters per second squared over 9.8 meters per second squared plus 1, which equals to 31.8 Newton. Sorry. 31.8 Newton. I hope you understand how we get the formula and how we get everything, because I'm trying my best. Anyways, let's go to the third part. Forgive me for that. Let's go to the third part of this example, where they are saying that we need to suppose that the woman in the figure, she's tired of watching the scale and exit the elevator. Then the elevator cable breaks, and the elevator is remaining its remaining constants are in the free fall. So what happens to the reading on the scale? So if things are in the free fall, what the formula is going to look like? So the formula is going to look like this. T equals to, this is the formula that we always use, am I right? So AY AY over G times plus 1. This is the formula that we are using still. So what is the AY in this situation? Since it's against the gravity on the y-axis, for example, let's talk about the y-axis and x-axis. The acceleration in this direction is positive AY. This is the negative direction, negative AY. So when we have a free fall, all the things, the content in the elevator is in the free fall, and like the gravity is going to pull them all the way down. Their acceleration is going to be, the acceleration is going to be minus 9.8. So, or minus G. That's how we can call it, minus gravitational constant. So T equals Fg minus G over G plus 1. What do we see from there? We see Fg equals minus 9.8 over 9.8 plus 1, which equals to Fg minus 1 plus 1, that equals to 0, and then that's all 0. So there is not going to be any type of on the scale we're not going to see any type of difference, because everything's going to be in the free fall. That's all. Thank you for watching my video. I hope you enjoyed and I hope you understood this problem. Thank you.